day, everyone. Thank you for the opportunity to present this work here at IBANESS 2026, Plovdiv. My name is László Péter Juhász. I'm a doctorate student of John von Neumann University Doctoral School of Management and Business Administration and a Tourism Institute master teacher at Budapest Metropolitan University. The paper what we bring here today is titled Trajectory Alignments After Shocks, a multi-stage regional diagnostic of structural modernization, resilience and sectoral drivers in Southeast Europe. It is a comparative measurement-driven diagnostic study covering 26 NUTS2 regions across 6 countries, namely Bulgaria, Croatia, Greece, Hungary, Romania and Serbia, over the period of 2000 to 2024. The motivation for this study comes from a well-known limitation in regional economics. Most convergence analysis relies on long-run averages in output levels or growth rates, while informative in stable periods, these summaries become misleading when regional trajectories are repeatedly interrupted by larger shocks. For the period of what we study, from 2000 to 2024, include not only one, but actually two major disturbances, the global financial crisis of 2008 to 2012 and the COVID pandemic of 2020. In Southeast Europe, these shocks played out very differently across all the regions. Some of them were just affected, others were severely disrupted, and some have not returned to where their structural path would have placed them. The first problem is that the long-run averages obscure this. A region can look like it is converging on average while actually falling further behind its own structural trajectory. Second problem is dimensionality. Regional performance is not one-dimensional. A region can have strong structural momentum but weak pandemic resilience. Here, a region can be stable but failing to transform its sectoral base. These distinctions matter for policy and for statistical reporting, and a single number does not capture them. Third problem would be benchmarking. To say that a region was resilient, we need a counterfactual. What would have expected without the shock? Without that benchmark, comparisons are just arbitrary. So the central questions what we try to answer is post-pandemic regional performance broadly consistent with pre-pandemic structural momentum, or are there systematic deviations, and if so, along which dimensions? To address these challenges, we designed a 5-stage diagnostic pipeline implemented consistently and computationally in Python across all 6 countries. The first stage is an estimation of the structural path. We fit a log linear Jánosi-style trend line to each region's GDP in PPS using only non-crisis observations, that is from 2000 to 2007 and 2013 to 19. This gives us the region-specific structural modernization rate, which we can call lambda, and the model fit statistic R squared. Here the path represents where the region would have been expected to sit if no large shocks had occurred. Stage 2 operationalizes resilience. Rather than a single resilience score, we separate the COVID-19 response into 2 phases. One of them is resistance, which covers the contraction from 2019 to 20, and the recovery, which covers the rebound from 2020 to 2024. Both are computed relative to a national hierarchical benchmark, normally the NUTS 1 parent aggregate, or the country level, so that we are measuring region-specific responses rather than common national shocks. Stage 3 asks a different question from the 2 stages. Here we ask which sectors are responsible for a region's divergence from the national average, and in that divergence due to the regional sectoral composition or to something specific happening in that sector. To answer this, we employed the dynamic shift share decomposition, which applied to nominal regional gross value added, so-called GVA, using Eurostat's NACE A10 sectoral aggregation. The baseline would be 2019, and the endpoint is the latest available year by the country, typically 2024 for the European Union countries and 2023 for Serbia. Importantly, the decomposition is executed strictly within each country, meaning all growth benchmarks are defined at the national level. This would prevent cross-country price level differences and contaminating the results. Every observed change in the region's GVA is algebraically partitioned into 3 components. The national shift, which is the portion of the GVA change that would have occurred simply because the national economy grew, which is we can call the rising tide component. It dominates all regions for all countries, which as we expect, because most of what happens in a region reflects what happens nationally. Second one would be the industry mix effect, where the portion explained by the region's sectoral composition relative to national sector growth rates. Here, the region heavily weighted towards fast-growing sectors nationally will show a positive mix effect, which would mean that weighted towards slow-growing or contracting sectors will show a negative one. Here, in this study, industry mix effects are negative in the majority of all of the 6 countries, here revealing that most regional economics in the sample are structurally overrepresented in below average growth sectors. The third one would be the competitive effect. This is basically the residuals, what is left after accounting for national growth and the sectoral composition. That would capture the region-specific over or underperformance within each sector, which relative to the sector's national growth rate. This is the most analytically informative component. It signals where a region is genuinely moving from above or below its weight in accounting terms. Stage 4 would mean the producers of deviation and lag diagnostics, specifically how far each region's current GDP sits above or below its structural path, and whether its relative lag to the national frontier has widened or narrowed since 2019. Stage 5 pulls all this across the 26 regions using a Z-score standardization and constructs a cross-country typology based on structural modernization rate and deviation from potential. Now we would like to demonstrate some of the results from the pipeline for each of the countries, and in the end the typology of the cross-country system as well. Here, when we pool all of these regions and standardize them using the Z-scores with 2 key dimensions, the structural modernization rate lambda and the current deviation from potential D, the structured cross-country typology emerges. Here, the pooled medians are lambda equals 0.032 and D sub I percent equals 17%. Here, the regions above the median on both dimensions are structural leaders, above on lambda, below on the DI, and potential catch-ups below on lambda and above on DI percentage resilient stabilizers, and below on both are structural laggards. Here, the most interesting finding from this typology would be that the country membership is strongly non-neutral. Regions do not mix random across quadrants, national patterns are clearly visible. The potential catch-up quadrant is dominated by Romania, 6 of 8 Romanian regions clusters here, combining the highest structural modernization rates in the sample with the current performance that sits below or close to the structured path, which is a very coherent story. It has the strongest structural trajectory. The pandemic interrupted it more severely than anyone else, and the recovery has not yet restored most of their regional path. The structural leaders quadrant would be BG41, BG34, the Sofia capital, AU12, the Pest region, and RS21. These regions that would combine the meaningful structural momentum with above of current performance, and they represent the genuinely favorable combination of the typology as well. The resilient stabilizer quadrant is dominated by the Greek regions, alongside with some of the Serbian and Croatian regions. As we discussed, these positive deviations in Greece do not reflect genuine modernization, but rather post-pandemic nominal recovery exceeding a very low baseline. Here, the typology would correctly identify these regions as stabilizers rather than leaders. Finally, the structural laggards quadrant contains 2 Hungarian regions and the Greek one, which is an important finding because these constraints are not purely Mediterranean phenomenon, but also the Hungarian regions from a generally well-performing national set share a laggard quadrant with a region undergoing energy transition contractions. The second slide in our cross-country comparison focuses on 2 patterns. The sectoral drivers tell us across the pooled sample and what the joint distribution of the resistance and recovery reveals. Here, the sectoral dominance would mean when we map the competitive effect profiles of the regions to their typologic positions, a pattern would emerge. Regions in the structural leaders quadrant tend to be associated with positive competitive effects in the tradable or higher productivity sectors, particularly the E covering industry and manufacturing, J for info communication technology, and F for construction. Regions in the stabilizers and lagger quadrants more often show competitive effects associated with non-tradable activities. Here, I want to emphasize that the important imperative discipline. The shift share competitive effect is a residual accounting term. It is not a measure of competitiveness in the economic sense. It is the region-specific deviation from what the national sector growth rate would have predicted. And in highly concentrated national systems, the capital region itself often appears to have a negative competitive effect simply because it defines the national average. For example, Belgrade, Sofia, and Athens are all record large negative competitive effects partly for this mechanical reason. In the most here interpretation is the always sector specific, always within country, and always within the benchmark as well. On resistance and recovery, the cost country picture confirms that these two phases capture genuinely distinct regional capacities. The regions that have performed well in both passes are geographically and sectorally diverse. These no single structural profile that guarantees the performance of both phases. The most interpretably interesting group here is the high resistance weak recovery cluster, which were initially sheltered but could not sustain above benchmark momentum. This pattern deserves further study. It may reflect defensive structural characteristics or provide insulation but not growth impulse. The final takeaway for the comparison is no country tells a single story. It is Hungary is internally coherent but has structurally constrained southern regions. Romania has extraordinary structural momentum but interrupted recovery. Greece has recovery numbers that look positive but conceal structural stagnation. And Serbia has one region that is the most extreme outlier in the entire study. This means that the heterogeneity is precisely what a multidimensional diagnostic is. Why necessary? First insight is that regional convergence is not one-dimensional. The full typology shows that regions with the highest structural modernization rates are not necessarily those with the highest positive deviations from the potential. And convergentially, several regions with modest modernization rates register strong positive deviations. A single convergence statistic cannot capture this, and comparative reporting that relies on it systematically can mislead. The second insight would be the concerns and the separation of resistance and recovery. These two indices should not be treated as interchangeable expressions for resilience. For example, we have documented multiple countries that regions can be highly resistant and yet weak in their subsequent recovery momentum. Some regions that were severely exposed during the contraction generated strong rebounds. These patterns reflect genuinely different regional capacities. One relates to exposure, structure, and economic buffers during a shock. The other relates to growth impulse and sectoral flexibility during a rebound. They are distinct, and treating them in a single scale would lose the distinction. The third insight is about sectoral attribution. The shift share decomposition consistently shows that industry mix and competitive effects pull in different directions across the set. Having a favorable sectoral composition does not guarantee above average residual performance within these sectors. This is an important implication that structural advantages in composition are not self-executing. Whether a region actually outperforms its national sector benchmark is a separate question from whether its mix is favorable. The fourth one would be the insight concerns interpretation of the deviation indicator. We want to be very explicit with the deviation. It is a trajectory alignment diagnostic, not a welfare ranking. Positive deviation in Greece does not mean Greek regions are prospering. It means that they exceed a very low counterfactual baseline, partly due to nominal post-pandemic recovery. The negative deviation in Romania does not mean Romanian regions are underperforming in welfare terms. It means that they have not yet returned to their rapid structural path. These distinctions are essential for responsible communication of the results. The conclusion returns to these three research questions that structured the analysis and provides the direct answer to each. First, we have to distinguish the structural modernization rates across the 26 NOTS2 regions, where the answer would be yes, and the heterogeneity is substantial. Lambda values span from negative values in some regions and the trend fit ranges from near zero in some regions, for example in Greece, and also above 0.98 for Romania region. Here, the Romanian and Greek regional sets define opposite extremes of this distribution, and it contrasts is not modeling on. It reflects real differences in the structural trajectory of these regional economies over the training period. Second, in the pandemic era shock response heterogeneous, we can say yes, and the key findings that the resistance and recovery do not co-vary as single resilience dimensions. The regions that have highly resistant in 2019 to 2012 were not systematically the strongest recoverers after 2020. Here, the pattern is consistent with the expectations from the evolutionary resilience literature, and it has direct practical implications. Reporting a single composite resilience index for a region contemplates two fundamentally different capacities. Third one, what are the sectoral sources of divergences? Here, we can say that the shift share decomposition consistently reveals that industry mix and competitive effects diverge in sign and in magnitude with a favorable sectoral composition, which is not sufficient for region-specific outperformance. This means that this suggests that understanding regional divergences require looking inside the sectoral structure, not just at its composition. All in all, the principal implication of this study is methodological. Comparative regional reporting strengthened when potential tough benchmarks face specific resilience indices, and sectoral decompositions are presented jointly and interpreted as complementary diagnostics rather than a substitutions for it. This is the methodological contribution we offer to the regional statistics literature. Before we close the presentation, let me flag the key limitations of the study which are important for interpreting the results responsibly. First, the potential paths we estimate are model-based counterfactuals. They are not unidentified structural quantities. The deviation from potential reflects where the region sits relative to an extrapolated exponential path fitted to non-crisis observations under a fixed functional form. This is the transparent approach, but it is still a modeling choice, and different modeling choice would produce different numerical results. Second, we apply uniform crisis exclusion windows across all 6 countries, namely between 2008 to 2012, for the comparability, but the timing and intensity of the crisis varied across the countries. For example, with the Greek debt crisis extended well beyond 2012. Here, the uniform window is a deliberate trade-off between comparability and precision. Also, the resilience indices are benchmark relative. They are inherently sensitive to the choice of the comparator. In highly concentrated national systems where a dominant metropolitan region shapes the benchmark, for other regions are mechanically influenced by the capital's performance. Here, the hierarchical fallback we implemented that would mitigate this but does not eliminate it. Also, the nominal GVA in the shift share decomposition, because deflated regional GVA are not consistently available at NOTS2 levels. Here, the nominal results should be interpreted directionally and within country only, not for cross-country magnitude conversions. And also fifth, the competitive effect of the shift share is an actual residual, which captures the regional specific deviations from the growth rates. It should not be described as the competitiveness without qualification because it embeds measurement structures, based effects, and compositional interactions alongside any genuine within sector performance difference. Regardless of these, we believe that the integrated diagnostic framework makes a very interesting contribution to how the regional statistic analysis can be constructed and reported. Here, the results are transparent, reproducible, and consistently applied across all of the heterogeneous sets of regional economies derived from Eurostat data. Thank you very much for your attention, and I am happy to take questions.